Okay, thank you. Am I on the mic right now? Thumbs up. Okay, so my name is Brock LaMeres, and I'm an associate professor from Montana State University, and I'm in the Department of Electrical and Computer Engineering. And my bio is basically, I'm kind of a traditional faculty, so I'm half teaching, half research. I've been doing this about 9 or 10 years now. And my area is primarily in the computer engineering side of things with emphasis on engineering education. So I wanted to share just a few of my experiences with online ed, and it involves kind of some interesting committee work in addition to some of the research that I've been doing with online labs and adaptive learning. So one of the first things that I've been involved with over the past couple of years is committees looking at just expanding online course offerings at my own university. And it's been kind of an enlightening experience being one of the few faculty voices on these committees. So they typically start with a statement such as, we're going to expand online courses. And everybody says, okay, that's great. Why? Why are we going to do that? And then it's, well, because everybody else is doing it. And then it's, no, we can't do that. We need a reason to do it. And then everybody says, well, to increase access. And that's like, okay, that's valid. So then everybody starts digging in and figuring out, it's like, how are we going to do this? And one of the big things that comes up is, how are these online courses going to maintain the same level of quality as our face-to-face offerings? And so then the discussions tend to revolve around that, and that's where the faculty can actually contribute to the discussion, and it becomes more of an interesting pedagogical discussion as opposed to an administrative and, financial side of things, chat. So there's a couple metrics that groups have come up with to actually try to define what quality is, and they're learning effectiveness, access, satisfaction for student and faculty, and cost effectiveness. And these are things that we've kind of used to guide our own discussions in these committees. And when you go through them, they're kind of interesting because some of them make a lot of sense. It's like cost effectiveness, it's like in access. We can all see how online ed that provides that. It isn't a leap to actually figure out that's something that it provides. Student satisfaction, whenever you say satisfaction, that's very tricky to actually measure because everybody is satisfied in a different way. One thing that's common about students, though, is that they want clear expectations and they want responsiveness. So if you ever want an online course to tank, don't respond to the students and you will get great course evaluations. And there is kind of more of a burden on the student when they take online courses, and it's something that, it's a challenge when you have, 18 and 19-year-olds that are taking a class online for the first time. You'll see this, that there's quite a bit of a challenge associated with that. Faculty satisfaction, who knows what this is about. So one thing that I learned that was really, really cool is that, when some faculty resist online education because they entered this career because they love interacting with students. They love talking face-to-face, forming relationships, and it's something that you lose with online education. So there's a resistance just because it's like, this is why I became a professor. I don't want to lose that just because it's the popular thing to do right now. And then there's also the burden of, it takes effort to develop these online courses, and nobody wants to be put in a situation where this year our school wants to push online ed, so everybody puts in a bunch of work, and then next year they change their minds and goes to something else, and you just basically wasted a lot of effort to create course content that's not going to be institutionalized or spread widely. And then another thing everybody's worried about, of course, is course evaluations. So whether you agree or not that course evaluations are a good thing, one thing that's interesting is that online courses, especially the ones that are just developed, tend to have lower course evaluations. And these are fascinating discussions for me because all instructors, we all sit around and we're like, course evaluations, they don't measure what we care about. They don't measure how good of a teacher I am. They don't measure learning effectiveness, and everybody dismisses them. The only way you can dismiss course evaluations is when you're getting good course evaluations. Try to get bad course evaluations semester after semester and use the argument, oh, they don't really matter. It's like, you will see if they matter to your institution or not. And the big thing with satisfaction, if you really get down to the heart of the issue with faculty, it's we really are satisfied when the students learn. So if that is above all else what you're after, and most of us, almost all of us are, then all these other things really don't matter so much. Then you get to learning effectiveness, and this is difficult. Okay, this is what we spend all of our time doing, because every discipline is different. Okay, every discipline teaches different. Even within one department, within electrical engineering, we have topics that are different. So it's like you can't apply the same methodology across all these different online courses. And there's learning domains, and assessment is absolutely difficult. Okay, so Here's an interesting exercise that I always throw into these discussions, and you want to side rail a committee meeting that's talking about quality of online ed, throw in the, well, how do we ensure quality of our live face-to-face course offerings? And everybody will, there's a big silence, and then, and then the meeting just gets totally derailed. Okay, so engineering has unique challenges because we rely on equation manipulation. And there used to be a day when this was a barrier, okay? There used to be a day when you would say, well, I can't write out the equations. And then computer tools evolved and everything, and we started using, videos, and we started using even like MathCAD, and you could have the equations written out. And then today, you can't use this excuse anymore that we can't write out these equations, we can't write the equations out. Writing equations is very important because it allows you to unfold the problem. So you're drawing them out, you're deriving them, and you're talking through it. And you can do that today, but what you lose in an online course is the student interrupting you and going, wait a minute, you just skipped a huge amount of content when you went from step B to step C. So that's really the key to those online equation manipulation. The big challenge with it is that you don't get interrupted by the student. The other thing is that grading engineering homework is more than just about saying pass or fail. It's about understanding the thought process of your student as they're working through the problem. And it's not only for the instructor to see where they're going and what you could have done to explain the material better, it's a feedback mechanism for the students. So they say, well, I started off good, okay, everything was great, then I biffed it, and then that's why I didn't get to the right solution. Okay? And this is a challenge because when you look at online ed, a lot of it is multiple choice questions. There are a variety of tools that are emerging that are just amazing in my mind with respect to trying to monitor how a student approaches the problem and all the interim steps that they go through in order to reach the final solution. And those are going to hopefully change the way online ed is in engineering, but they're not quite there yet. It's a challenge. And partial credit is a killer too. You watch students take multiple choice questions, they're geniuses at it. It doesn't even matter the content area, they can figure out a way to guess the right answer no matter what the content is. They're just brilliant test takers when it comes to multiple choice questions. Okay, so another one is the laboratory component. Okay, so Bonnie was talking about this also. Labs are crucial to engineering. Okay, this is how we apply the information, and it allows a student to develop across multiple learning domains. So this is something that engineering really has going for it is labs. You talk to people that are outside of engineering that don't have access to labs, and all they ever talk about is how they want to get active learning and get their students engaged. And what they're talking about is they want to mimic what we do with our laboratories. So the laboratory component of our classes is just essential to actually teaching the material. Okay. Now, there's a lot of challenges, there's a lot of limits what we're talking about, but the potential is huge. So accessibility is a big deal. I mean, that is, even though everybody says that's why we want to do it, and it's mom and apple pie, it really is a big deal when you think about non-traditional students, lifelong learning, and workforce training. Personalized learning is one of the big things coming up in the next decade that I think is going to really change the way we do online ed. And then the cost. The cost is real, okay? So everybody, everybody's talking about the student loan debt, and it's now the #2 personal debt in the country. This is a huge deal because it's going to change our profession. So just like the dot-com boom changed the tech industry, just like the housing boom changed the real estate industry, this is going to happen to us. Our profession is going to change in some way in the next 10 years because of this crushing debt that our students have. Okay, so real briefly, a couple things that I've been doing at Montana State University with respect to actually researching engineering education is looking at online laboratories. And so online laboratories tend to fall into 3 broad categories, and there can be hybrids of multiple categories, but in general, online labs fall into one of these 3. One of them is portable lab kits, okay? So this is what Bonnie described, where the student actually purchases something and then goes off and can do this thing on their own. There's pros to this. One of them is it's becoming increasingly affordable. There's also cons to this because the difficulty is that not all courses can use this. Okay, so electrical engineering, we benefit because we can actually have these portable lab kits. And then scaling can be an issue too, because if you think about you're an instructor and you forgot to order the lab kits and you're a week before the course starts, and then you go, I have a MOOC, I need 50,000 portable oscilloscopes. That manufacturer loves that order, but he's not going to be able to fill it in a week. So the second category is remote control labs. So this is where you actually have specialized equipment on campus and you allow the students to access it from off campus. And this is a picture of a remote setup that I had at Montana State. So it's a microprocessors lab where this is the microprocessor board. They're writing assembly code. They actually have a logic analyzer attached to the board, and they're taking measurements. And these are great because it allows access to specialized equipment, but the downside is that it does require support staff. Okay, there has to be somebody there that's setting it up, making sure that when it crashes, you reboot it. And again, not all labs can be done this way. The third category is a virtual lab, and this is where you try to use software to mimic what's going on. And with 3D visualization, you're getting a more sophisticated virtual lab experience. So these ones have the promise of scalability, and they can be cost effective as you scale with volume. The problem with this is that students don't believe them as much as you might think. When you talk to them, they're like, that was a real cool graphic, but I didn't really learn the concept. I didn't really believe it. And then a software bug in this thing can destroy the entire learning experience. So there's some cons to that too. Another thing that I've been looking at recently is this adaptive learning, so the personalization of education. And this is where online ed can, or just computer augmented learning has huge potential when you talk about creating a learning experience that is personalized for the student, okay? And this has a lot of impact with stuff like getting different groups more represented in engineering and, lifelong learning and stuff like that. But the whole idea here is to basically create something that adapts the material to the student as they perform these formative assessments as they work through the material. And it's historically been just difficulty of the material. But what we're seeing now is that you can do other things such as wording the examples or wording the problems or the type of examples that you use to better reach certain students. For example, like when we talk about batteries, electric batteries for cars or something, in Montana, the application of using that battery for something that, I'm getting the buzz here to get off stage. This is my last slide. But using the example that battery has to operate in a negative 60-degree climate, right? That's a real application for our students in Montana State. These are ranchers and farmers, and they understand that. You do that in Southern California, and they're like, sweet example, Professor LaMeres. It's like it doesn't have the same impact. So imagine that you log onto these systems and you enter information about yourself, and then the material is adapted to give you examples that are more relevant to your background and your life experience. Okay, so like I say, this is not the answers to anything. Hopefully this will spur discussion that we can talk about later at the affinity groups. Okay.